So before getting into it, does anybody have any specific questions about anything in the chapter? This one was a whole lot of just get a feel for Rust and how it feels to work in the language more than anything specific. Or beyond questions, like any thoughts, opinions.
See, no questions for me. I guess like an opinion would be, um, like I don't know, it's just a small sampling of like Rust in general overall, but Rust is supposed to be like extremely type safe, and I like saw like inside that room just like a glimpse of okay, so I understand, I definitely understand like for example, using specific signed and unsigned bits, for like an integer, using mutability for those bits and integers, and like how it all like ties together just to make things, I would say, a lot less error prone.
Yeah, for sure. If you're coming from a language with less number types, it'll be, especially something like JavaScript where there's one number type, it'll be a
Yeah.
whole different world.
hmm I remember in college, I took a few CS classes because that's what my degree I called for. It was in computer graphics, so um, a few core CS classes. I remember first time I took, I think, yeah, it was intro programming. It was in like C++, and actually I failed, but then I had to take it again, of course. And second time around, I understood a lot more. But now, sorry, I'm just dominating the mic. I apologize. I just wanted to share. Um, and Rust is, it's C-like, but I think it's like definitely easier entry for a lot of people. It helped me out quite a bit.
Yeah, that's a lot of what it talked about in the intro chapter as well. Like it's trying to be equitable, so you don't have to know all of the things that make a good C programmer. It'll just let you know, okay, so maybe you shouldn't do this one thing because it'll cause some nasty bugs down the line.
Yeah, exactly.
Yeah. Anybody else have any thoughts, questions, concerns? Everybody end up getting it working, or anybody have any trouble?
I cheated. I used my old program that I made when I went through it the first bit before.
Can't believe
I'm
it.
sorry. Forgive me.
I went through it again, and it was very nice understanding everything this time around, and I found out like a few new editor shortcuts that helped me out, which I will show off for any VS Code users. Very nice. Ooh. Okay. Sounds good then. Feel free, as always, stop me at any time for questions. But I'm just gonna run through it and sprinkle in some thoughts as we go. Okay, so starting out, we set up a guessing game. And then for review from last time, run our program with cargo run. So here's our default program, hello world, our default executable. And from there, it's giving us a few different things in here. So the first thing we do, process our guess. And the first thing we end up doing is make a string and write to it. So how do we do that? And then just from here, from not copy pasting, here's a few of those cool little shortcuts I found. So like if we do a guess equals string new, and then here I just do IO, it'll autocomplete that. Very nice.
Ooh.
And then from here we can read line, and we're going to read to our string. So if I just do this and I'm unsure what to do, Rust will be very nice, telling me exactly what to do. So it expects a reference, and it expects that to be a mutable reference. So I can fix that and change that to a mutable reference. And then once I go back, it's telling me another error, which is a little bit harder to understand if you're unsure. But here in Rust, if we don't have a semicolon, it's assumed to be a return, an implicit return. So we're returning the result of this function. So it does tell us right here both of those things, and we need to consider using a semicolon. I wonder if the code action will work for that. Oh, it does. Perfect. Beautiful. And then here it says...
Oh yeah, quick question.
Oh, go ahead.
Oh, sorry.
You're fine.
I was just thinking. So, is Rust Analyzer is it Rust official, like LSP, or does Rust have its own LSP and Rust Analyzer is like, I just got it's a library? No, it's not a library. Well, it'll just be an LSP, but
I believe it is official, but I am unsure.
oh, that's awesome. Let me see. I can just look it up myself. I don't know. I just wanted to ask about it. I'll just look it up myself. I apologize. Let's see.
Yeah, I'm unsure.
Thank you.
Yeah, if you find out, let us know. I think it'll be... I'll check it out real quick. Shouldn't take too long. Oh, okay. That is not copying for me.
I think it is.
I don't think it's like official, but it looks to be sponsored by Mozilla.
Ferris.
So it's at least endorsed by people affiliated. So I'm unsure.
Gotcha.
Looks to be open source.
The open source collective. All right, I apologize. Sorry, I just like have sudden thoughts and I wanted to share. I apologize.
I think you're fine. Yeah, go ahead. Yeah. I'm going to see how much of this I can solve with code actions because it looks like I can do everything with it. Okay, so next step, change it to be mutable. It's immutable, which is the next thing to get into here is we can't mutate a variable unless we specifically say that it's mutable. So here, if we put mute here, it's now mutable. And here we're getting something else. And finally, our code actions can't save us anymore. But yeah, at this point, we have an unused result. So it's forcing us to deal with our error, our potential error. So reading a line, we could potentially have some kind of system error here. So if that happens, we need to do something about it. So we can either error out if we can't do anything about it, or maybe ask again. And that's one of the very nice parts of Rust. You don't just throw an error, and you know exactly what functions can throw an error, pretty much. Well, in this case, it's not throwing an error, it's returning a potential error. So here,
One question on that
oh, go ahead.
readline. That buff colon, that's not, you didn't type that, right? That's just like part of like one of your add-ons or extensions is filling that in?
Yeah, that's
Like
an inlay hint.
a parameter name?
Yeah, exactly. This parameter is called buff here. So it just lets me know. Just like this
making
string
sure it wasn't
here.
part of the syntax in the,
Yeah. I mean,
like when you were passing it.
I wonder. I don't think you could. Does that work? No, not at all. I figured it wouldn't work, but yeah, so inlay hints are pretty nice here because I can figure out exactly what types everything is with just looking at it instead of opening up this little tooltip menu, I think. So yeah, another great thing about Rust, since we're talking about inlay hints, is we don't need to specify what type this string is. It just knows it's a type string. And all the things we can do with that are now verified because it's a statically typed language. But it's very nice that we don't need to say this is a string because clearly this is a string from string new. Yep. Any questions beyond that? Perfect. Okay. So here we can use expect. And here it mentions that it returns the value if it's okay. And if it's an error, it's going to panic, which is the equivalent of throwing an error. So it does mention it's generally discouraged, but in this case, let's just assume that we decided we can't do anything about it. Like our guessing game doesn't work if we can't read the line. So we error in this particular case.
So when you say panic is essentially the same as throwing an error, you mean like in like JavaScript or something, if it throws an error, because then it crashes the program.
Exactly.
Unlike in Rust, where usually you would use like a result to return like a possible error, like you said before.
Yeah, it's your final way out. Like you can't really save yourself at that point. So you're going to panic and crash the program as opposed to.
But then it like always crashes the program. So it's like you don't get like an error out of it. Or I guess you would do, like you would get like a trace back or something, but you wouldn't be able to like handle it, is what I'm saying. It's going to kill the program pretty much.
Exactly. You
right?
don't get to handle it. There's not really a try catch as far as I know.
Right. Okay. Yeah, that's
in
all.
Tests,
so you handle
though,
all that with in tests?
Oh, sorry. Yeah, in tests you can. There's a macro for expecting it to throw. So there's some way to do it, but I don't think you'll run into it with typical non-test Rust code because if you're writing library code or your own code, you're not going to want to throw in there.
Sure I understood the distinction between those.
Oh yeah, exactly. So result type and option types can either be okay or so they have some value within. So in this case, it's either okay and writes to this guess, or there's an error and it'll tell us that error. And for whatever reason, for this example, we've decided this is not recoverable. So we're just going to error in that case. That makes sense?
Yeah.
Okay. And I'm going to write a Rust FMT real quick because I want that to be on different lines. Why am I doing a semicolon and Tamil? I do not know. Yeah, beautiful. So yeah, we're getting inlay hints here as well. So here we get a result type, which is an enum. So it can be one of two things. It can be a usize, which is an unsigned integer, depending on the architecture you're using, and then an error. So if we save that, or the value of this, I don't know exactly what that usize would be. Maybe like number of bytes written. I'm unsure. Oh yeah, right here, number of bytes read. Okay, that makes sense. It's read line. So here, but we are mutating this guess variable here. Okay. And then here, so and then here we can interpolate our guess into this string by adding these curly braces here, or we could also write it directly in here if we wanted to. So I'll go with this just because I can. But yeah, right here. So let's see, I'll input my guess and let's say 5, and my guess is 5. Any questions so far? Okay. One more thing, since it did come up last time, is what do these colons here mean? And in this case, it's an associated method, or sorry, an associated function. I believe it's associated function. Let me verify real quick. Yeah, it's an associated function. Great. Okay. So the difference here between something like a method is we don't need a value to do anything with it. So if we have, there's no self value. So if I change this, we could see everything that we could do. So we have new, which doesn't require itself. So here we have to string, and then another one that will be familiar is length. So getting the length requires an instance of the string. It requires self. So if we call new, we don't need any strings to do it with. We just call it and it works. But if we wanted to do something like guess.length, then in this case, we would need a string to do it on. So similar to a static method in other languages. Any questions there?
I'm good.
Perfect. Okay. Then I'll get into it more. So I think we went through a fair bit there. There's a lot of explanation in the book chapter that I'm scrolling through right now, sorry. Oh, okay. So moving on to the next portion is generating that secret number. So here we want to install the RAN crate, and we want a specific version. So we're going to go to our Cargo toml to go install that version. And we want to install version 8.5. And now we can use that crate. Oh, okay. So then we don't even try to use it there, but we immediately update, but we may as well look at it then. So to use this, the specific methods they want, we have to bring a specific trait into scope, which just implements some features that we're going to use. But for the purposes of this, I think it's fair to just ignore it because we'll get into it later on and it's a pretty tough topic to start out with. But yeah, now we're going to generate that secret number with brand. And then here we're taking in a range, so we want 1 from 1 to 100. And here's another great part of Rust is the range syntax. So if we're doing a for loop like this, we could loop through 1 through 100 pretty easily. And then this equal sign just means it's inclusive. So we're going to 1 to 100. But if we were doing this dot right here, then we'd be going through 1 through 100 again, but it's not inclusive. So there's 1 through 100. Any questions there?
Is just a double dot a non-inclusive range? Or do you have to use
Yeah,
equal?
exactly. Yeah, just to show it off, I will do a nice for loop then. So if we did like 1 dot dot 5 and we print I in here, we have to install rand, but yeah, we get 1, 2, 3, 4. But if we make this inclusive, we do an equal sign, it's going to go all the way to 5. Very nice syntax. That makes sense? I didn't hear anything, but I will.
Oh, sorry. Yeah, I think my mic was muted.
Okay. Are you good?
Yeah.
Okay, perfect. Yeah, so moving on from there, removing that number. Since we're using rand, it's going to pick a different number every time. So 38, 29. But then at this point, we want to import a different thing. So we can compare it and use another different enum. So we'll do some actual pattern matching this time instead of just expecting. But here's one of the very nice parts of Rust. So they mention this right here. But at the current moment, these are the wrong types because we have a string and we want to compare it with an integer type. But the one good thing about all of these things is, oh yeah, perfect there. So this could either be less, greater, or equal. And if we don't add an equal, then we have an error. So there's no way we can forget about any of those. And you can expand this a bit to do certain numbers as well. So you could do like 1 or 3, and then any number greater than 5. And then from there, you could match everything, which we can get into if we have more time at the end, but it works for so many things and it stops so many little errors from things you'd forget normally. But yeah, if we try to run the program, it's going to tell us the same thing here. So it expected an integer, but we gave it a string. So we need to somehow turn that into a string. And the recommendation here is to change guess. So here we're shadowing it by declaring guess again. So that means from this point, guess is no longer mutable. And all references to guess are going to talk to this guess instead of this higher up guess. So this is equal to the old guess, and we're going to trim it as well as parse it to a U32. And then expect again. And then at this point, it should work. So if we input 6, it's less than our number. And then here our number's 4. If we guess the right answer, it's 4. And then here 88, if we do 90, then we say too big. Any questions so far? I did not show off
I'm all
that.
good.
Oh, sorry. That
You're
scared
good.
me.
I was just saying I'm all good.
Okay. So if I type in something that's not a number, it's giving me this not very great error message. So I don't remember if we get into better error handling, but if you're running a program, it's definitely not best practice to just kind of show off the the trace like this. But for now, I think it makes the most sense to do it that way. And then here, the book mentions, so this only lets us do one guess, so instead we could loop through everything. So we could take this whole section here and run a loop, which just runs everything, or runs forever. So it's like a while true. And running this here, we can do a few answers. So all of these work. We can do 70. I don't remember what the original one was, but 46. But our program keeps going if we win, so that's definitely not what we want. So we need to stop looping at that point. So instead of just printing here, we can add curly braces to add another expression. So instead of just printing, we can also break. And running this, 50 is too small, and 58 works. Oh, we do get into it. Any questions so far, though?
Do you have an extension that's just auto formatting your code?
Rust FMT, let's go. Yeah.
Okay. Does it just sorry? So it does that just on save, I guess.
Yeah, I have it set to format on save.
Nice.
Yeah, so my editor does that, and then I have it set to Rust Analyzer has that built in to format with Rust FMT.
Is that something you set up in the extension or like in your cargo toml or something? Not the cargo toml.
My VS Code.
Like, does Rust Analyzer have like a separate config or something?
I have a few things set up there. Let me see. So if I go Yeah, I set it up in here. So my default formatter for Rust is Rust Analyzer.
Cool.
So I set that up myself. But I believe, I'm not sure if it would do it on its own, but I think so. And if you don't have it set it up and you're using VS Code, I will drop this in chat for you. Okay. Any other questions from there? Cool. Okay. So then, right after I was talking about the error handling here, we get into it. So instead of expecting please type a number, we can instead do something else. So they recommend using a match statement here again. So if we match guess.trim.parse, then from here, we can do things and we can see we have OK and error arms for our result type. So we need to decide what to do. So if we're OK, in this case, we're just going to return that number. And if we have an error, in this case, we're going to just continue. We could also mention some kind of error message in here. But this is what they're going for here. So that's what we'll do. And going through that. Oh, sorry, go ahead.
I may have missed this before, but for the guess.trim.parse and then like the scope resolution into a type, like what is that? Is that just like a variant of the parse function, or I don't understand what that is? Because
it's a generic,
I was thinking like
pretty much.
Okay, because I was thinking the double colon was working sort of like in C++, but I didn't know you could reference something like that. Like, well, I don't understand what the U32 is. Does it call like a different function that like of parse that's for U32s specifically?
It's called the turbofish operator, and I definitely deviated from what the Rust book does. So if we do U32 over here instead, that works equivalently.
Turbofish.
But yeah, it's called the turbofish. So I got a little bit ahead of myself. But what happens if we don't do that is, or don't match anything, it's going to say, I don't know what type this is. What type did you actually want to parse to? So yeah, it goes for a different implementation from one thing to another. So in this case, it knows we're coming from a string. So we're calling from string, but we're turning it into...
So the parse function can take like a type, like a parameter almost.
Yeah, exactly. Okay, yeah. It tells us the answer right here. I don't know why I was Googling it with you, but so it can cause, parse is very general, cause problems with type inference. So parse is one of the few times you'll see the turbofish. It'll help the inference algorithm understand which type you're trying to parse into. So if
So
it
that way
implements
you
from
just don't
string,
have to add all those types to like the rest of the line, like guess U32 and all that. It just sort of implies it.
here ultimately it doesn't matter because we can put it beforehand. Like we could put it right here and it's fine.
Okay, so it is just one instance.
Yeah, here it doesn't matter.
Interesting.
We have to put it one place at least to tell it what it is. I don't think we could do it here if we did. Oh yeah, we definitely cannot do it there. Yeah. So we
Well,
could
it
do
has
it.
to be yeah.
Yeah, we can do it here and we could do it later. But if we did something else after the parse, then we would have to use the turbofish here or save it in a variable beforehand.
Oh, okay.
So a lot of the time it can be inferred, but not every time. Especially with a function like parse, which is just, in this case, for parse on a string, is calling fromster.
Yeah.
Oh yeah, we have right here.
Generic stuff. I didn't. That's like. Yeah, that's around where I gave up last time. What is this, chapter 10? Generics and traits and lifetimes? Yep, that's.
Yeah, we are. I mentioned I'm not going to get into traits because it's going to be confusing. And this is something involving traits. So let's just say it's magic. Yeah,
Move on.
it works
Yep,
amazing.
magic.
And
I love
there's magic we definitely will never find out about until, yeah, but we'll find out about it in later chapters. But just for now, just know it works. Yay.
Sorry for the tangent.
You're fine. So now we don't really get to see anything because we're just continuing at this point, which is nicer to look at. Maybe we could also say something else. I don't know if it mentions, oh no, it doesn't mention anything else, but we could print this error. We could do something else. And here, this underscore is just saying we're not using this error at all. But we could do something about that and say error. So we have a parse int error here. We could print it. And let's say print line, look at that error. Which is not in a string, of course. We're not in JavaScript right now. But running that again, if I say 8, I mean, obviously that works. But here we found invalid digit found in string, which is our error. But you'll also see here, we have to be very explicit. And bringing back JavaScript again, you could pass 0 arguments or infinity arguments, but here we need to pass exactly 1 argument and be very explicit that we don't care about this argument. But yeah, at this point, oh, go ahead.
Sorry, I'm just gonna ask about the parameters to the error function trait. I don't know what exactly it is, but
the error here, what ERR is?
Yeah. Is
that is a variant for an enum.
Oh, okay. Yeah, I see. I gotta get it.
Yeah. So like it's one of
the
two things here.
Is that like the only? Oh, that's just it's just a convention, right? To say we're not going to use this, but you could use like another variable name if you wanted and just not use it. But would the like compiler yell at you or something?
I call it like whatever I want. Like I call it this pile of stuff. It won't.
Okay, it'll just
error, but it will warn. So it runs, but it says, hey, if this is intentional, please prefix it. So we could prefix and then it knows, okay, that makes sense. So
Oh, so it just
beyond,
expects a leading underscore.
yeah, for
That's
conventional
like, we're not going to
purposes,
use this thing. Okay.
yeah, it doesn't hurt
Cool,
anything, but it
cool.
does tell us something about it. Like, for example, I could do it in JavaScript as well, and my editor will gray it out because it knows I won't be using it. So it's convention in a lot of different languages.
Yeah, I was just asking because it's similar in like Python,
Yeah.
where it's just convention and like, but like you can do different things. Like if you do a double underscore, it'll actually like mangle the underlying function name or whatever you're referencing, but it won't actually like do anything else. But again, it's just like a convention. So I just didn't know if Rust had stricter requirements or not.
I don't think it'll cause any issues if you do it, but if you have like
Just
exactly what I did
warnings.
here, Clippy's going to say, hey, if you have multiple underscores or multiple or digits, then maybe you want to do something about that. So just one
Oh,
underscore.
is that a different warning? The double underscore
Yeah, it gives you different warning.
versus like an underscore and then like a alphanumeric or alphabetic name.
Yeah, one underscore is saying, okay, that's fine. We know this is some kind of error that you're not using. But if you had multiple arguments in there, multiple parameters, then maybe you should name these or be more descriptive about what you're not using. So you could turn that off if you'd like, but I think it makes sense because it gets kind of confusing looking at something like that. Yeah, does that make sense?
Oh yeah, I'm good.
Okay.
Yeah.
I think from here we're pretty much done though. That's all the book gets into for this portion. So we can do our game correctly. So 44, it's too big. Something else that's a letter breaks. If we do 55 with spaces, it does work because it's trimmed. And if we guess the actual number, which is 35, let's do 1. -1 will fail because it does not fit within a U32. So as well, something like that will fail. And then finally, if we go to 35, we complete the game and we win.
First try.
Yeah.
Cool.
Yeah. I think we'll definitely get it more into match statements, but there's like super cool stuff here as well, which I'm tempted to get into, but I will not. Anybody have any final thoughts, questions?
I had not pertaining to Rust, but I had a fun little realization while playing the guessing game. Like the quickest way quickest way to solve it is essentially to do like binary search.
Mm-hmm.
Not like implement it, but like as a human being, you're doing binary search. You know, you divide essentially 1 to 100 is an array. You divide half and half. You know.
Yeah.
Never thought of that before.
Yeah, let's go. Thinking algorithmically.
Does that break need a semicolon after it?
No, I don't think so, but it adds it in my formatter. Let's see. If I save without formatting, is it fine? I think it is. Yeah, it's perfectly fine. But it's like a matter of opinion. So
Yeah.
something like this, print line returns unit type. So it returns,
Unit type? Like a unit vector? Like a unit.
oh, it's not even going to tell me the
Let's
return
see.
type. But yeah, unit is the parentheses. So if I do like a 7 here, it's going to say it expected this, which is unit. So it expected void essentially, so no return, and found an integer. So what you can do is this will compile and run perfectly fine. But the semantics here, and this is definitely a stylistic and opinionated thing. So if I say like print line down the line, return something different, then I'm saying my main function returns what print line returns if I do this. So if it changes down the line to return like a number, then I'm saying it does. But in actuality, it doesn't return anything ever. So it's a matter of semantics. And in break actually returns something sometimes.
What? No.
Oh no.
Come on.
Oh no. For loops you can return something. This is terrible.
That can't be.
It's true.
No.
Let's do it.
Oh my. You're right.
So let's say let num
When
equals
associated with a loop, a break expression may be used to return a value from that loop.
let's
This is
do some
only
awful
valid with
code.
loop and not with any other type of loop.
Yeah. Oh no. We're gonna make I because we feel like it. This is not good code, but we're doing it for the example. So yeah,
Is
we
fine
let num
if it's an
equals
index.
this. Right now it is type bang, which just means never because it'll run forever at this point. I don't know if it's called never, but it's just it's what happens when your function never returns because right now it's not returning.
What? How do I look that up? I just looked up never. Primitive type never. Oh, that
Oh,
works.
it's called
Yeah, there
never.
it
Okay,
is.
cool. I'm glad
That's a nightly thing. That's only experimental.
It's not nightly. It's a part of the
Well,
language. The type it is.
maybe the never keyword is.
Okay, so at this point, it's telling me unit type can't be printed. Of course it can't. But yeah, if we say we're going to print once we hit a certain condition, so we're going to do I plus equals 1. And then here, we're going to say if I is equal to 5, we're going to break and return I. Or we could break and return whatever this is. Me being bad at Vim, but pretend it's not. So here, this is different type. And then at this point, if we run our code, it's going to return this number. Well, it's not a number, but we're going to return this value from the loop. Or if we say break I, we'll get 5.
Oh, yeah.
So that is another
I could see how
reason.
that could be useful.
So like it's
Did you
kind of
read
like a return.
Yeah. But it says, oh, there's the loop. I was wondering where the loop. I didn't see the loop keywords in there. In the docs, it does say that the never thing is nightly only experimental.
That's interesting.
I mean, since 2016. So, like, it's been around a while, I guess. But there's still, like, recent comments on the open issue for it.
Can I like see this in here? Because I'm definitely not using nightly.
I don't know. I linked it in chat, but then there's a link to the related issue at the top of the page.
Can I click into this? Is this a type? Oh, it is experimental, so I can't. You're right. I can't define it myself or specifically say this is type never. But it does exist. I appreciate the distinction though between something that returns that doesn't returns unit versus returning never.
Yeah, I don't. I mean, it has, I guess, a different like use case. Like you're only supposed to use it for a thing that doesn't return. Is that the whole point of it?
Yeah.
Yeah, I've used it before. Specifically, when I was building an operating system in Rust, so the main function there is never going to end because until you close your operating system. So at that point, it was just runs forever. But also, some other keywords have type never, which is like return. This has type never.
That's weird.
But yeah, there's a bunch of cases where you might want an infinite loop just to check for certain things, run certain processes.
Huh.
But yeah, I don't think we'll run into it that often. It's just like a fun little edge case at this point. I don't think I've ever run into it for those cases, but if you see it, just know you did something weird, or if you know what you're doing, I guess you can leave it that way. Your choice. Yeah. Any more questions about that, or should we move on to fun match stuff?
It also, I'm reading through the documentation on it now. And so it makes sense to use it whenever you're implementing your own traits for things that aren't supposed to panic because they'll never return, I guess. Very strange.
It's like you mentioned Python, like never return, or I don't know exactly what it's called in Python.
I don't know if Python has like a primitive like that.
It does. Like if you write a function that just raises.
What, just like a blank raise?
Oh, it's called a no return. Yeah, look at this. Yeah, if you just raise. you write a function that throws an error and that's it.
Mm-hmm.
So that is no return.
Wait, what is it called? No return, all one word. No return.
Yeah.
Can't find those docs. What the heck?
I'll send them over.
Thank you.
Yeah, no problem. And then before...
Oh, it was the type hints one. I thought it was something else.
Yeah, it's a type int.
Okay, so it's a type hint. It's not like a primitive in the same way it is in Rust. It's just like any of the other, because the type hints don't really do anything in Python.
Yeah. It means something.
But it can like mark it if it's like, oh yeah, this is just like arrays and that's it.
Yeah, it's good
Just
for
good to know
verifying your
this.
code works at compile time. But yeah, it's kind of the same. Maybe I'm totally wrong on this, but in Rust, it's guaranteeing this and doesn't compile in that case. I guess your Python works and it's your editor or LSP that's telling you like you can't run this like this.
Yeah, unless you're running like some static analyzer, like I think like Pydantic or something else, it'll just run and the type hints don't do anything unless you run it through a specific like static analyzer after, like before you run it, basically. But Rust, I assume like it has more guarantees for like, oh yeah, it just won't compile if you use it wrongly.
Yeah, it's like all built in, so you're not really going to do it. I have never seen a way to get around stuff like that because that's not really like a lint, but there could be a way, but I'm just going to say there isn't. Okay. But yeah, on to match arms before we sit here for 2 hours again. Yeah. So like a super...
Rust.
yeah, we're super... yeah, where we get like super derailed into really complicated side topics, which are cool, but I don't want to like scare anybody away.
It may be inevitable with Rust, to be honest.
Okay. So for this, we have a missing match arm. We have I32. It's everything in I32, which is from, I don't remember exactly what numbers, but I guess we'll find out. So what does this say? Yeah, we have every single number missing here. So if I do 1, let's return, I don't know, it's 1. And then here, okay, there we go. So we're missing from the minimum to 0 and 2 from the maximum. And then it's saying, hey, okay, so if you want to fill this in, you can match all these rest of the ones that we were missing. Or we could also do a wildcard and select everything. So this is something else. And this is fine because if it's 1, it'll say it's 1. Otherwise, it's something else. We can also do like 3 or 5. And if it's 3 or 5, then we'll say 3 or 5. And then we can also do a range. So like 4 to 900. And that will work. Except for this one won't catch 5 because it'll hit the first one that it matches and then skip any others. But that just shows a lot of the power of a match statement because I can't possibly forget any number this number could be because every single number is matched here. Thank you for coming to my TED Talk. Use match statements.
Yeah. So match is basically just treating anything you give it as like an enum, right? So like even though it's an integer, like you have to enumerate everything. Like you have to return a valid like value within that range. Right?
Yeah, you need to make sure you're catching every single pattern exhaustively.
What did it say? Every pattern must exhaustively. Okay, yeah. Cool.
Yeah, you need to get every single thing it could possibly be. So we could either do it explicitly, catching every single number, or we could implicitly say, if it's something else, then do that.
So I guess you don't have to give a type for the match statement as long as the number you're passing has a type. Is that just part of like the inference?
Yeah, we don't need to pass it a type, but it must be the same type. So if I change the type of this, then it says, okay, this variable is not just one type. It's multiple types. That's not a thing that can happen. And then, yeah, this match arm is matching everything in the set of I32.
Was this in chapter 2? Or is this
It was in
just...
chapter 2, but there's more on it if you go to chapter 18, which I honestly have not read. But yeah, it gets into all this stuff if you want to read it right now.
It's actually pretty short, or at least the second part is.
I think I'll wait to read that until later.
Definitely fair. It's an extra credit assignment for sure.
I mean, I think it's probably pretty useful, even if you want to do it early, because matches are used all the time. Like constantly. Like every time you do anything, you basically have to use a match if you're gonna like handle errors and everything. But I guess yeah, you probably don't need like all the advanced stuff for most of it.
I'm going to say it's tougher if you haven't worked in a language with enums in them, or you haven't worked with structs, any of that kind of stuff. It makes it a bit more difficult to handle. So I think what you see there, like the language saying, okay, here's what you need to do to make sure this works, I think that's good enough.
Yeah, you could get by with the
But look at that, we have control flow statements. I wonder if there's a match statement in here. There probably is. Maybe there actually isn't. Oh, I guess not. Oh, pattern matching is in chapter 6. So we'll get to it in chapter 6. So that's pretty soon. You don't have to wait till chapter 18 though.
That makes more sense. I was gonna say I don't like.
It goes more in
I was
depth.
pretty sure there couldn't be just match in like chapter 18 because I didn't get to that last time.
I mean, yeah, like it gave you more of a taste. Like some of your questions, like how does it match a literal? You can find that out because an I-32 is not enum. So how does that work? And you can figure it out. But I'm not going to get into it right now. But yeah, let's move on. Oh, sorry, go ahead.
Yeah, for me, it feels like a more elegant switch statement, sort of.
Yeah, for sure. It's similar.
Yeah, similar, but it handled way nicer.
Yeah, there's no fall through.
It's
It's
a bit
very
more.
nice.
Yeah, it's stricter. But yeah, I agree. I think they added a match statement to Python recently. I need to play around with that. I don't think it works. It probably doesn't work the same as Rust, really, but
It can't be nearly as elegant unless you handle
No.
your own types.
No, yeah. I think it's probably mostly to I remember reading something about where it's like it's sort of convenient to replace in Python all the like if else chains that you're sort of stuck with since it doesn't have a switch to begin with. But I think it's also used for like similar pattern matching style things like in Rust, but it probably just isn't as strict since you don't have the typing of everything in there, so it may be a bit more loose. If that's the right word for it.
Non-exhaustive switch statements.
Yeah,
Or
not
wait,
exhaustive.
match. Okay, let's say match statements. Wait, these are matched expressions. Who knows? Ooh. But yeah, that's another great thing about Rust. Like if statements are not a thing. We have if expression, so you can save the value out of it. So there's no such thing as a ternary. It's just an if expression. And then match, you can save the value out of it, and so on. Very nice. And you can just
what? So wait, is if not like a regular control flow thing then?
It is, but you can save its value. So like let num equals, let's say num2. Num equals num is greater than 3 or 4. So if num is greater than 4, we have 4. And then else we have, let's say 8.
Oh, right.
And then this is the equivalent. I mean, pretty close to Python. But yeah, you can do this. You can put it on multiple lines. But it's just super nice that you can save the value of tons of these things. And then even if you want to scope something differently, you can say like let hi, I don't know, equals this, which is just some block. And whatever this block returns will be the answer. So this is an I-32. And you could do something much more complicated in here if you'd like. But yeah, super nice. And yeah, before we spend too much time, let's get into homework for next time. So now that we've gotten into
no homework, rebellion.
You can skip it if you want. I recommend you go through it. You learned a lot of stuff. Might remember some things, might not, but it's worth skimming through at least.
I don't need to remember stuff.
Okay,
Ridiculous.
your choice.
Sorry, no. What was this? Chapter 3?
Yeah, chapter 3. So we'll be going over variables and mutability. So what I talked about, what was in the last chapter, but more in depth, some basic data types. So exactly what we were just talking about, and a reason why I didn't go super in depth with it. Woo. So
Foreshadowing.
oh no. Foreshadowing. Ooh, look at this. Talking about those number types, floating point numbers. This one's a little tough if you haven't messed with it, but ooh, tuples. Tuples are great.
I love tuples.
Functions. Those are great too. We can finally do something other than just throw everything in main. Parameters. I love parameters. And then we get statements and expressions. Ooh, exactly what I was just talking about. Whoa, fancy. And we get into return types and everything. This pretty short chapter on comments, but pretty
As it should
typical.
be.
And control flow.
If you need a long chapter on comments, I think you've designed your language wrong.
There's
It
some
should
good stuff
be-
on comments that's not in here. There's so much you could do with comments.
There's like a lot of like documentation commenting and stuff you can do in Rust, can't you?
Whoa, look at this. Amazing. Yeah, you can put code in your comments with doc comments and run tests in your
Yeah.
comments and so many other things. But we're not going to get into it now because we don't want to. Whoa, look at that. Returning values from loops. I wonder if you should read this chapter.
I wonder where that could, yeah. It's okay, we already went over it. I don't need to read that one. We went over that.
Oh, okay. Yeah, maybe
You
we
skipped
don't
ahead.
need to.
Yeah.
Okay, I'll make sure not to talk about it so I can force you to do the homework next time. Looping. Amazing. But yeah, this is some super good, good review and some great other things like making for loops that'll be very helpful for everything. And then there's some
Very
cool
important
stuff
looping.
here. I recommend doing these little practice problems here, like convert temperatures between Fahrenheit and Celsius is pretty tough if you've never dealt with all those number types before.
Print the lyrics to the Christmas Carol, the 12 Days of Christmas.
I don't think I ever did the last one, but the first two are
Yeah.
pretty cool. Yeah. Cool. Any final thoughts, any questions, comments, concerns?
Nope, I'm all good. I'm excited to start getting into the main concepts. I think it's going to be interesting talk.
Yeah, super cool stuff.
Can't wait to get to the ownership and borrowing section.
Conveniently, chapter 4's ownership.
Conveniently, chapter 4, yeah.
Will, are you going to read that chapter? Hope so.
Yeah, of course.
Cool. Okay.
Oh,
No,
chapter
that's
10
definitely
is
where Sorry, go ahead, Rami.
chapter 10 is hard.
Yeah,
because
that's yeah.
That is a very hard chapter, or very hard topics
Traits
at
and
least.
lifetimes. I'm going to be sick that week, everyone. I'm sorry.
Oh, okay.
So in this chapter, he keeps mentioning, okay, this is covered over there, this is covered here. So I kept going back to other chapters to see what exactly is it. So yeah, like error handling. This I also went through that chapter, error handling chapter, because I didn't like the way error handled in the chapter too. Like the error guessing game, it was bugging me.
Yeah. I mean, it's great that you're seeing that it could be done better right now. So you'll be thinking about it when you get there.
To panic or not to panic? Excellent question.
Yeah,
That's the name of
yeah.
of the panic chapter.
I like to start every function with a panic. Helps out pretty nice.
Just to show him who's boss.
Shouldn't have run my code. Can't trust me.
Right. Just unsafe and panics all throughout your code. every other function.
Oh yeah, you're right. I can use unsafe and make the program crash in a better way. I don't know how to do that
In a
yet,
more
but I'll
structured
learn.
way.
I'm pretty sure it wouldn't be too hard because unsafe lets you just do whatever the heck you want. It basically like turns off the compiler. Sure. Or all the safety checks or whatever, at least.
I don't think it turns off every safety check. A lot of it's still there,
Well,
but
probably, yeah. I need to. Actually, it doesn't matter. I shouldn't be writing any unsafe code. I don't need to. I shouldn't look up what I can get away with that. Be a bad idea.
I mean, there's some stuff you can do in there that you can't normally do,
Ooh.
but it's not like you're just completely out
Yeah.
there. Just always
But you
remember,
can-
if you're writing C, you're always unsafe.
Yeah, I was gonna say it's chapter 19.1, by the way. If anyone wants to look and see what unsafe does.
I read that chapter already. Ooh, spooky.
Okay. But yeah, you can like just get a null pointer and dereference it. Easy. Crash. Access or modify.
Just because it sounds kind of spooky, unsafe doesn't really. I think unsafe isn't a great name for it because it doesn't turn off the borrow checker, disable safety checks or anything. It's just kind of like it allows you some extra things that you aren't allowed to do in safe code that you might actually want to do sometime, but it can't guarantee that your code will do anything weird in that time. So if you have to do it
I
for
mean,
like
it's
speed or
still-
something, make sure to quarantine it.
Know what you're doing, yeah.
I mean, yeah, you definitely know what you're doing. And at this point, we definitely should not be reaching for it at all. But yeah,
Unless
no.
no.
If the compiler tells you not to do something, don't do it right now. If you get better
Look,
at
I
Rust,
want
maybe.
to write C in my Rust. Okay?
Absolutely not.
You can't tell me what to do. You're not my mom. I can do whatever I want.
You won't even read the chapter, so how are you going to find out?
Shh. Joke's on you. I'm reading it right now.
Okay. I think
Reading it
that's
out of spite.
I read the chapter. Like I skimmed it. I read it, kinda.
okay.
Most of it. I promise I'll read the next chapter, okay?
Okay.
Alright, I'm about to get going. Getting late
Yeah,
here.
sounds good. I'm
Yeah.
gonna end off the recording here because we're kind of just talking.
Some fun. It's all good.
Yeah.
Yeah.